Quote, our results show that learners who had access to the AI code generator, the Codex group, were able to successfully generate code and showed evidence of understanding the generated code during the training phase. They performed significantly better on code authoring tasks, 1.15x increased progress, 0.59x less errors, 1.8x higher correctness, and 0.57x less time, with no decrease in performance on the following manual code modification tasks, in which both groups performed similarly. Furthermore, during the evaluation phase on the immediate post-tests, learners from the Codex groups were able to perform similar to the baseline group despite not having access to the AI code generator. In the retention test, which was conducted 1 week later, learners from the Codex group performed slightly better on coding tasks and multiple choice questions, although these results did not reach statistical significance. Finally, our analysis indicates that learners with more prior programming competency may benefit from AI code generators, end quote. And that's from page 2 of the publication titled Studying the Effect of AI Code Generators on Supporting Novice Learners in Introductory Programming. This paper is written by Majid Kazemitabaar, Justin Chow, Carl Ka-To-Ma, Barbara J. Ericson, David Weintrop, and Toby Grossman. Apologies if I mispronounced any names. Here's the abstract for this paper. Quote, AI code generators like OpenAI Codex have the potential to assist novice programmers by generating code from natural language descriptions. However, over-reliance might negatively impact learning and retention. To explore the implications that AI code generators have on introductory programming, we conducted a controlled experiment with 69 novices, ages 10 through 17. Learners worked on 45 Python code authoring tasks, for which half of the learners had access to Codex, each followed by a code modification task. Our results show that using Codex significantly increased co-authoring performance, 1.15x increased completion rate, and 1.8x higher scores, while not decreasing performance on manual code modification tasks. Additionally, learners with access to Codex during the training phase performed slightly better on the evaluation post-test conducted 1 week earlier, although this difference did not reach statistical significance. Of interest, learners with higher Scratch pretest scores performed significantly better on retention post-tests if they had prior access to Codex. End quote. If I were to summarize this study into a single sentence, I'd say that this study found that students who had access to AI code generators while learning how to code outperformed students who did not have access, even when engaging in manual coding exercises. And that right there is a fascinating little finding that we're going to unpack in today's episode of the CSK8 podcast. Now, if you don't know who I am, my name is Jared O'Leary. I've worked with every grade, kindergarten through doctoral student, in a variety of contexts, from music education to computer science education classes. You can find my CV on my website, jaredoleary.com. While you're there, you'll also find over 180 other podcast episodes, as well as some interviews with some awesome guests and solo episodes like this where I unpack scholarship in relation to computer science education. Now, this week's episode kind of builds off of last week's episode, which was talking about plagiarism and ChatGPT. So this study is actually going to look at, well, what happens if we use code generation when learning how to code? Now, there's an idea called distributed cognition where, as an example, you can take a tool and it will allow you to focus on higher level processes rather than the mundane things, like a calculator. Instead of focusing on like multiplying and carrying the one, etc., blah, 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 you can instead focus on like using the calculator to give you the result that you're looking for to then apply that result into like your construction project or whatever. So thinking about the bigger picture rather than focusing on the mundane task of actually doing the mathematics. Generative AI can do the same thing. So instead of focusing on writing out your for loop, you can just instead write out a simple prompt that fills in your for loop that, I don't know, maybe is 20 lines of code long for an entire function. And you can just copy and paste that into your application and write it out in, I don't know, let's say half the amount of time. That is a potential benefit when you are using generative AI to help you write code. But there can be some drawbacks with that. So what happens if you don't have access to that tool? Like, let's say the server's shut down for ChatGPT for a day, but you have a deadline that you have to meet when authoring that code, and you can't do that because you might not know how to do it. You are 100% reliant on AI writing it for you. Or what if the AI is wrong and it creates an error and you can't fix that error? So while on one hand it provides some affordances, using it also creates some constraints. And so we need to kind of consider this and explore it. So this study is actually going to do that by exploring 5 different research questions. This is from page 2 of the PDF. Quote, RQ1, are novices able to utilize AI code generators to solve introductory programming tasks? RQ2, how do learners' task performance measures, e.g. correctness score, completion time, and error rate, differ with and without AI code generators? RQ3, how does learners' ability to manually modify code differ with and without the use of AI code generators? RQ4, what are the effects on learning performance and retention from using an AI code generator versus not? RQ5, what is the relationship between existing programming competency and the effectiveness of using AI code generators in introductory programming? End quote. All right, so the next section is on related work. So they had subsections in here on natural language programming, on AI coding assistance, introductory programming, etc. So if you're interested in learning more about some scholarship that explores those areas, then make sure you check out that section. The following section talked about the AI-assisted learning environment. So if you want to learn more about how to create your own version of this and like what they did when considering it, like on the implementation, data instrumentation, programming task design, quality of AI-generated code, etc. Check out that particular section. Let's talk about, okay, well, what was this particular study? So this is under the user study section. So there are 3 phases to the study. The first phase was like a 2-hour-long introduction to how to code, specifically with Scratch. The second phase was a training phase. So this is where the learners were in 2 different groups. One group was just learning how to code without AI code generators, and the other was actually using that to help them code and to go through 45 programming tasks and complete 40 different multiple choice questions. And then in the third phase, which is the evaluation phase, this was kind of like a post-test. So this phase, nobody was allowed to use the AI code generators or the Python documentation or receive any feedback on the coding task assignments, and they basically had to do a post-test to see whether or not they still remembered the information or the things that they learned during the training. Now, in the study, there were 69 learners, 21 of them were female, 48 were male, and they were all in the age range of 10 to 17, and they had a different range of background, demographics, etc., which you can check out on PDF page 6 on the bottom right corner if you're interested in that. You can also check out the data collection, discussion, and data analysis, but I'm gonna skip that because I don't think that'd be interesting for this particular podcast. So let's get nerdy and get into the results, starting on page 7. In the training phase, overall, the completion showed that the people who were able to use the Codex, which is the AI code generator, were able to finish more of the tasks than the group that used the baseline. So the Codex group had a mean of 90.9% completion, whereas the baseline group that did not have the code generator only completed 79%. Their correctness score was also much higher, so the group that had the AI was able to get 80.1% for the mean as compared to 44.4% for the baseline group, and they spent less time doing it. So the mean seconds for this was 210 seconds for the AI group, whereas it was 361 seconds for the baseline group. So that is a huge difference in all these different categories. And the Codex group actually used less documentation than the other group. So they used it 22.1% of the time as compared to the baseline group, which used it 54.3% of the time. They had less errors overall. Most of the errors were syntax errors, and in general, these errors were less than the baseline group, but they had the same amount of like semantic errors across both groups, or a relatively same amount, so 0.01 and 0.03. Now, at the top of page 10 is a chart or a figure that is on the statistics of tasks in which the AI code generator was used, broken down by topic. So the topics were basics, data types, conditionals, loops, and arrays. So it talks about what percentage of time did students actually use the AI for the different ones. So for like the basic stuff, they used it 48% of the time. For data types, they use it 61% of the time. For conditionals, 75%. For loops, 84%. And for arrays, 85%. So as it got into more complex topics, then it seems like the students were using the AI code generator more than they were at the beginning. This figure also breaks down the number of multiple usages for each one of those, whereas like compared to a single use, as well as the number of tasks that were 100% completed by the AI generators, and then the percentage of time that they actually just copied the question directly from the code generator into the answer. And you'll notice as it got more complex, they did this more often. But a question that I have is, were they running out of time, or was it because they just found it was easier than actually typing it out, etc.? Was it a causation in that as it got more complex that the students relied upon the AI more, or is it more of just correlation in that it just happened to be the complexity was kind of unrelated to it, and really it was just like the time in which that something was introduced? So like as they got later on into this particular study, they're running out of time. They're like, let's just get through the arrays and the loops. Let's just copy and paste this. It'll save me some time. And I'm not sure about that. But the authors do note that even though these like percentages are interesting, the patterns were not consistent. So like some students use the AI code generator a lot, while others who had options to it barely used it at all. So there's like this large continuum, this large spread between usage. It wasn't consistent among the different students or participants, which is a great great point that the authors made. Now, one of the things that I personally would be afraid of with students learning how to code using generative AI is, well, maybe they're not actually going to learn the concepts. They're just going to rely on this tool doing it for them, which is what I've often heard some people say with mathematics concepts. Well, you need to write it out by hand, otherwise you're going to rely on your calculator and you're not going to understand it. Well, in this particular study, they found, quote, although learners in the Codex group used the documentation less and relied heavily on AI-generated code for the authoring tasks, they still did just as well, and in some cases better, in manual code modification tasks, end quote. It's from page 10. That is such a key finding right there. We really need more studies to kind of like follow up with this and figure out, is this something that is found in other areas with other platforms, etc.? Because if so, that is a fascinating result. Honestly, one that I wouldn't have predicted. What it's basically saying is, hey, we could use these code generators that allow students to learn something faster, and they're actually scoring better than if they hadn't used it. Right now, I'm looking at these findings and going, what's the downside here? Why would anyone not do this? Especially when we look at the evaluation phase, which is like the post-test, and you find that both groups perform similarly on all three different tasks that were measured, in terms of the authoring tasks, the modifying task, and the multiple choice tasks. And in some of those tests, the students who used Codex, the AI code generator, actually performed better than the students who did not. That is really interesting. Now, before we sing our praises to AI code generators, there were more errors from the students who used Codex when they were doing the manual coding. So they had a mean of 1.58 errors compared to a mean of 0.99 when there was no starter code provided. So they're making slightly more errors, but not enough to make me go, yeah, we shouldn't do this. This one did have some statistical significance. However, they also had slightly more errors when modifying tasks, but that did not have statistical significance. So again, more studies would help to figure out why this is happening and whether or not this is generalizable outside of this population. Now, the authors also had some qualitative feedback. So they asked students what their perspectives were on this, which is great. So just looking at only how well students performed is something that a lot of researchers end up doing that kind of like leaves out a larger piece of the puzzle when it comes to educational psychology. Like, yeah, a student may have performed better on this, but did they walk away from the experience going, wow, I really hate that subject area? Because if so, that's something we need to know and figure out why. So it's great that they were not only looking at what was learned and the retention of that learning, but what students actually thought while doing this. More researchers should do this kind of research where it's looking at this broader, more holistic approach to learners and learning. So kudos to the authors for this. Here's a quote from page 11 that's interesting. Quote, both groups felt they learned about Python programming and its concepts during the training phase. However, on stress and discouragement, learners in the Codex group felt slightly less stress, U390.5 at p-value of 0.056. Some learners from the Codex explicitly attributed their reduced stress to using the AI code generator. For example, participant 26 reported, quote, using the code generator helped me save time and reduce pressure, end quote. And they've got more quotations from the different participants and whatnot that kind of reinforce this. So in general, not only did the students perform better, but they actually liked it better. Some small percentage of students said, hey, I'd actually prefer to do this on my own rather than use a tool that does it for me. I might be that kind of person. I kind of like the struggle because I feel like I'll learn more through the process. But at least with these participants, that might be more of an outlier than the norm. All right, so the discussion section is really neatly organized with the different research questions. So the first research question was around whether or not can novices use AI code generators. The answer is yes. So the second research question, which is how do learners' task performance differ with and without AI code generators? Well, they perform better with the code generators. The third question is how does learners' ability to manually modify code differ with and without code AI generators? And the students who use the code generators were able to perform just as good, if not better, than the students who did not use that when they were doing the post-test that did not allow anyone to use the code generators. That's an interesting finding. The fourth research question, which was, what are the effects on learning performance and retention from using AI code generators versus not? So they found that this doesn't impede the learning results, and in fact, it might lead to better learning results than not using it. And the final research question, RQ5, is what is the relationship between existing programming competency and the effectiveness of using AI code generators in introductory programming? And what they found is that if you came in with a higher pre-test score, you are likely going to benefit even more using the code generators than if you had a lower score. So if you have prior experience with learning how to code, and then you are going in and adding in an AI code generator on top of this, It might make it so you can excel and learn faster at a better rate and get through this faster than if you did not have that prior experience and were using the AI code generator. So this may be an accelerant for those kinds of students. Now, the authors mentioned the use, modify, create framework, which if you're unfamiliar with that framework, check out episode 26. That was well over 150 episodes ago, which is titled Computational Thinking for Youth in Practice. So if we think of like use, modify, create with modding video games, so making a video game do something different. So the use would be just playing the video game. The modify would be actually modding the game, where you're changing the code that exists, and creating would be like, hey, I have this blank IDE page, I'm going to create a brand new game from scratch. So that continuum of like playing versus modifying, changing a little bit versus creating something from nothing, and in between each one of those. So the authors talk about how AI code generators can be a form of this. It could be like a crutch for students to be able to use the AI code generator and eventually be able to modify the code that is created by it, and then eventually be able to get to a point where they can create it without it. But a question that I have is, if it ends up saving you time and you get the same amount, if not better understanding, why would you even get to the modify and create when you could just go with the use and learn how to create code with AI in collaboration with the AI rather than modifying what's given because the code might not work very good, or creating it from scratch from on your own? Like, I have a drum kit behind me. I could learn how to whittle my own drumsticks, or I could, just buy some from the store and then focus on making music with it. It's the same thing with programming. Instead of focusing on like whittling away by writing out lines of code, maybe instead I want to just be able to very quickly create this thing and then use that program to do something, like to play a game or to do whatever. So here's an interesting quote from page 13. Quote, "The benefit of AI code generators for novice learners could be explained by the effective employment of the use, modify, create pedagogical strategy often used in introductory programming. Although learners in the baseline group use the documentation more frequently, they had to start each task by creating a new program from scratch before getting to the modify portion of the activity, and thus encountered more errors. However, learners from the Codex group had the advantage of using code that was generated specifically for an intended behavior that they wrote. This meant that the AI coding assistant turned the create task into a use modify task, as they were provided with functional pieces of code in response to the written description, which they could then modify. Therefore, they were able to spend more time to trace, test, and learn about the structure of the generated code before moving on to the modifying it in the next task." End quote. That's a great point. So if you're able to spend more time creating and thinking rather than actually writing out lines of code, is that a win? Especially if it doesn't lead to learning loss, but instead potential learning gain over not doing that approach? So on page 14, the authors talk about, okay, well, what are some of the potential implications for design? So they talk about supporting complete beginners. So AI assistants could be used to help them out. They talked about control for overutilization of these tools. So if you are over-reliant upon an AI code generator, they provide some suggestions in there. And they also talk about how you can use this for creating some writing prompts with the classes that you work with. So if students are unfamiliar with how to prompt an AI to create something for them, you could generate some prompts for students to work with, or create a list of prompts that students can kind of like use to start their line of thinking with the things they want to create in collaboration with generative AI. So if you want to learn more about those ideas, because I just kind of tease them, make sure you check out page 14. Now, at the end of these Unpacking Scholarship episodes, I'd like to share some lingering questions and thoughts. So one of them is, how do the findings for the study compare with studies on students using Stack Overflow? So as I mentioned last week, Stack Overflow is like a repository of questions that are related to programming, or people will say, hey, I can't figure out how to get my program to do blah, 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 blah. And people will respond to it with code or with a description of how to solve that problem. Professional programmers often say that they frequently go to places like Stack Overflow, and they will often copy and paste and then modify slightly to make it so that the code works in their particular program. That's something that I've done on different projects that I've worked on, etc. But I imagine that there are some studies out there on whether or not people learn something when they are using Stack Overflow. So it'd be really interesting to kind of compare those studies specifically on copying and pasting from Stack Overflow with studies like this one that are actually looking at generative AI and that kind of collaboration that could go on in a classroom. But last week's episode kind of shared some more questions and lingering thoughts that I had about using generative AI and plagiarism when it came to coding. So if you want to hear more about that, make sure you check out last week's episode, which was episode 187, and again, it was titled, Will ChatGPT Get You Caught? Rethinking of Plagiarism Detection. If you enjoyed this particular discussion on generative AI, there are many more podcast episodes. There's currently over 187 other episodes, as well as some bonus April Fool's ones if you're interested in those. But if you check out these show notes at jaredoleary.com, there are multiple episodes that are specifically related to AI, like episode 13, AI for All, Curriculum Development and Gender Discourse with Sarah Judd, episode 142, Teaching AI in Elementary School with Charlotte Dungan, episode 173, Empathetic Listening in Computer Science with Josh Sheldon, and episode 176, The End of Programming, and last week's episode that I already mentioned. If you enjoyed this episode, consider sharing it with somebody else or leaving a review or just simply pressing the like or putting a comment in the YouTube video that you may be listening to this on. Stay tuned next week for another episode. Until then, I hope you're all staying safe and are having a wonderful week.